Okay, let's switch again to English because our next speaker is Oliver Bähler. I hope the pronunciation is correct. Now it's time for a real use case. So, as senior engineer at Bedag Informatik, Oliver will lead us to the journey its company went through with some lesson learned and what to do and what not to do next time. So, hi, Oliver.
Hi, Serena. Thanks for the introduction.
Great hat.
Yeah, I thought it was asked that I should wear it, so but I can show
Okay.
off that I have an entire collection, so not only the yellow one, but also a red one.
Okay, so thank you. The stage is yours. Let's see you.
Okay, so thanks for having me, guys. I think some of you might already have lunch around this time, so I'm trying to get through as fast as possible. So what we are looking at today is our journey with Kubernetes Tenancy that we had over the last few years. And I want to show you what we've learned, what we've done wrong, and what actually went well, and what we would do again. So first, again, about me, I'm Oliver. The pronunciation was correct, like it's Bähler. I'm 23 years old. I'm something like an SRE. It's always difficult to be specific on that, but I do that kind of stuff. I finished my apprenticeship like 4 years ago, and since then I've been working on Kubernetes. So mainly doing maintenance, deploying apps, etc. I just noticed that some of the icons don't show up in the presentation. There should be a fire truck and the fire on the Kubernetes, but that's fine. So, and I work for Bedag. I want to introduce my company as well because that's going to be important. So Bedag, we are a limited company which is fully owned by the local government of Bern. So we're based in Switzerland. And since we're owned by the government of Bern, we also provide most of our services to the local government of Bern, which means we don't directly compete in the open market. But yeah, our main customers is Bern, basically. So we have these three different branches. So our biggest branch is basically the solution. So we develop and maintain individual and standard software for the local government. One of the examples would, for example, be we have a software which allows to hand in the taxes via mobile app so that the local citizens can easily hand in their taxes. And we basically develop and maintain that application. And there's other such use cases, basically everything that, or most of the part which the government needs. And with that comes the second branch, which is the full outsourcing. So we basically provide different hosting service from colocation, which means just space in one of our data centers, to complete PaaS applications. So for example, Kubernetes belongs into that branch. And there's also a third branch, which is workplace services. That's basically so we ensure that all the workers which work for Bern have a managed namespace. So the managed client, we roll out the clients and basically make sure that they can work. If you want to check us out, the webpage is www.bedag.ch. So I want to introduce you to our Kubernetes landscape, that you also have the understanding of how big our operations are. Currently, we only run Kubernetes on-premise. That's because it makes the most sense, and because most of our apps have the requirement to be deployed in one of our data centers. Our main customers is the solutions branch, so our internal developers which deploy and develop the app on our Kubernetes platform. And we basically have these two offerings. So we offer a managed Kubernetes, which is we take care of the operations and the lifecycle of the nodes, etc. And then there's the other part, which is the integrations part, which is something like DevOps. So basically, we have the engineers which have the specific know-how to deploy apps and operate them on Kubernetes, and will basically help the developers or the customers to deploy their apps on top of our managed Kubernetes service. And since the beginning, we had a tenancy commitment. I wasn't part of the beginning team of Kubernetes, but basically the idea was we have a high operational burden with a shortage of workers or know-how regarding Kubernetes. So therefore, we're trying to split up clusters and share resources. And for that time, also most of the use cases didn't justify a dedicated cluster. And also there's the aspect of sustainability, so that you don't have to run too much VMs just for one single application. At the bottom, you see kind of the specs. So right now we have 14 clusters with around 202 nodes. The numbers on the right don't add up. There's one VM missing, don't know where it is, but that's around the scale we have regarding VMs. Within these clusters are development clusters. We have also dedicated clusters for a central Elastic stack, and all of the other clusters are basically for all the application workloads. So something else which might be familiar to you guys, but I also want to introduce that to you, is I want to show you how our Kubernetes value stream is built up, and it's basically split into the 3 different circles. Starting from the left, the blue circle is basically the service which provides the managed Kubernetes. So their assignment is to bootstrap the clusters, manage the VMs, and basically ensure, hey, the API is running. And in average, we have 2 engineers which maintain and also develop the workflows to ensure that these clusters are up to date and can be bootstrapped. And there's the middle circle. Nowadays, you call it platform engineering. Before, it really didn't have a name. I guess it was somewhere hidden in DevOps. But it's basically when you start to enrich the Kubernetes API with operators and start to configure them, that all the users which use the platform have a better experience. So, for example, you take Capsule, you take Prometheus, and do some configuration so that the end users have a better experience interacting with the platform. There we have around 0 engineers. I would consider it my hometown because I've done most of it, but basically it's a shared burden between whoever has time and what's the problem that needs to be fixed or addressed. Yeah. And then on the right, we have the integration service. That's basically where all of our DevOps takes place. As you can see, we have 8 engineers there, and they're confident with deploying apps on the given service from the platform engineering or directly on the platform, and basically ensure that the customer's app is deployed, is reliable, and is operating. So as you can see, most of our projects take place in the integration service part. So most of our customers want one of our engineers to take their app and actually deploy it and look that it's working. Only a small margin, it's around 10%, and I guess even less, but are directly accessing the platform and are doing all their stuff by themselves. So now we're transitioning into how we built our first tenancy. As said, I wasn't part of this, so it's just a bit history for me as well. But back then, the expectation was, or when we built the platform, we want to have that namespace as a service offering. And basically, each namespace would consist of resource quotas and limit ranges, which would then be called quota profiles. And an offering for a customer would be then based on a namespace with the corresponding resources you would need. The code base for that was the guys spinned up a custom operator, which was based on Ruby and also utilizes Meta Controller and Kubeless, both projects which are now deprecated. I believe Meta Controller is forked. And the workflow would look something like this. So basically, the customer would tell the platform service, hey, we have a need for resources, so which translates automatically into a namespace. And the platform service would assign or create a new tenant with a namespace, and the namespace would hold these limit ranges and resource quotas. Talking from a CRT perspective, it would look something like this. So you have your tenant construct, but each namespace which would join the tenant is statically declared. So in this case, we have the foo namespace, which is statically declared on the CR, so the implementation of the tenant, and which would have this quota associated with the tenant. So that would be, for example, its best effort, which then basically translates into a limit range and a resource quota, which wouldn't allow you to request any resource. So it's really best effort according to QAS. Something else that would be ensured is some network policies so that you couldn't escape the namespace. So basically that you couldn't access any other tenant's namespaces or even other namespaces within that tenant. And some basic role bindings which would ensure that the admin service account would have access to the namespace. With each tenant, there would be a reserved namespace. For one reason, we would deploy an admin service account, which would then ultimately be the access for the customers to the tenant. But way back, I don't know if some guys still remember, but with Helm v2, we still had that tiller server, which was required to deploy your Helm charts within your tenant. And so that we could also do that as deliver that as a tenant, we had to deploy the tiller on a tenant basis so that you could deploy Helm charts. So yeah, but that's long gone. So the scenario effectively, so here's a layout of how our cluster could be distributed. So we have a classic segment, for example, and the location A and the location B. And let's say we have location A, which is production workload. And it's important to understand that we consider development stages, if they pay, as production workload, because if the devs can't work, it's kind of like an outage, especially since it's our main service. So we would need to deploy the tenant on both of these clusters. So on the location A cluster, there would be a customer tenant, and on the location B, there would be a customer tenant. And since we would statically declare these namespaces per tenant, we would deploy the tenant with the def and prod namespace onto location A and just a test on location B. So effectively, then the customer would get two kube configs in that case, because you have two separate clusters, and would use those two kube configs to access his specific stage. The problem that comes with that is, since you're building some sort of tenancy within the Kubernetes API, you cannot grant things like list requests on the namespace API. So basically, the people have to know how their namespace are called. So we built a web GUI where that's explained, or where they can see how their namespaces are called, so that they could access the correct namespaces. And we also built some feature with Grafana, so each tenant would have its own Grafana where they could check their logs. But let's not get into that. So, oh, that's unfortunate. The learnings from that first implementation was that for that time, it was a good solution at the time. So it worked. I'm not sure if there were any alternatives at that time, but I guess they looked around. All the resources are controlled on a namespace level. So you had the assurance per namespace that, for example, production had this fixed amount or could implement this quota policy, etcd. And also for that time, it was kind of important that the deployment and review was done by administrators, because back then the know-how was only coming up for the Kubernetes platform, and for most of the people, it was still very abstract. Sorry. Yeah, now there's this text box over my field, but that's okay. So one of the major drawbacks is that the entire implementation is too complex, and it's really difficult to maintain, especially if you have 3 different components and write your own code base. And each time you would require a new feature, you need to adjust the Ruby code base and make new releases. It's kind of difficult, especially if you have a shortage of people. Then the experience is difficult for the people, or as mentioned, so API list requests are not possible, so you can't list your namespaces. And something else that was then complained about is, hey, we cannot create our own namespaces, which is, all right, that's fine. The process and the scalability, so the workflow, how the namespaces gets bootstrapped was kind of overhead, since you would always need an admin. And back then we still had shared workers. If that's negative, that's not important, but we also didn't really implement some kind of policy engine. So it was difficult, or we couldn't basically enforce the workload to have certain requirements. So, for example, I want all the workload which is scheduled within this tenant or namespace to only use priority class A, or schedule on these nodes, or something like that. That wasn't possible, or you would have to write an additional feature. So, and the customer feedback, that's the box in green, was basically, hey, it's taking too long to create a namespace. What's going on? Can you make this faster? So we came up with the Capsule Tenancy in 2021. We just discovered Capsule after their KubeCon presentation. And basically our expectation was, let's shift from one namespace as a service to a tenant as a service. So basically the offering would still be based on resources, but the resources wouldn't be scoped to a namespace, but instead to a tenant, so that you can create as many namespaces as possible. Our migration plan was to take the previous tenant features, or at least try to be as one-to-one as possible, and also in the same move to migrate to GitOps. Previously, it was a push-based CI system which deployed the tenants, and we wanted to move to Flux. And the biggest requirement was use existing framework and deprecate everything we had. And that's when we chose basically Capsule and Capsule Proxy. So the new workflow would look something like this, that the customer would again say, hey, I need some resources on Kubernetes. And then they could create within a GitOps repository their tenant, and then the platform service would just give their approval. And once that tenant is bootstrapped, you basically have your resource pool, but you can create as many namespaces as you want. So quick talk about Capsule. So Capsule is basically a framework which helps you to create your own multi-tenancy model. So it introduces the tenant construct to the API, so to the Kubernetes API, which isn't there by default, and also helps with certain policy enforcement, which can be scoped on tenant basis. So this helps to basically build your tenants how you need them to look like, or build higher abstraction models on that tenancy model. So if you want to check it out, there's the links to the GitHub repos, and Dario is also in the chat. So, and it's maintained by our friends from Classics. So if you look at the tenant CRD, which is implemented by Capsule, it looks already a bit more sophisticated. So we see that the quota is on the tenant object and can stretch over the entire tenant. That means the resources are no longer bound to static namespaces, but can be stretched. So that's the main point. No more static declarations of namespaces. You can declare ownership to a tenant via the native Kubernetes airbox. So you can assign the groups and users and service accounts which are available. You can design network policies and role bindings, which are then ensured within each new namespace. So that means all these profiles which are on the tenant are then always replicated within each of the new namespaces which is created. So for example, if a customer creates the namespace Solar Showcase and I've some role bindings on my tenants, it's ensured those role bindings are actually deployed within that namespace, and it's ensured they are present. And there's the policy part, basically, where you can define, hey, look, within this tenant, we only allow the usage of this storage class, we only allow this ingress class, only this ingress URL, or only you can only pull images via this registry, which basically helps to ensure that even if you have a shared cluster and have, for example, multiple storage classes, but you don't want to share them with all, you can also enforce that via that policy system. And as mentioned, the ownership is native to Kubernetes. I have to say, we also moved to OIDC for the Kubernetes API server. So we could capture groups which we got from the IDP and could assign them directly to the tenant, which was great. So we could move away from those technical service accounts to personal users. Here, just a brief look on how the architecture looks like. I don't want to go too deep into it, but that's the combination when you use Capsule Proxy and the Capsule Operator in combination. So basically the entry point for each of the users is still the API or maybe the Capsule Proxy API, but you can basically hide that between something like Tremolo or a load balancer. But they would access the API with their kubectl get stuff, or even could access it with a Kubernetes dashboard. And what then happens is basically that list requests, which are required, for example, to list the namespaces, are captured by the Capsule proxy and basically intercepted. And the Capsule proxy then looks up all the namespaces which the current user is associated with, so where he's a owner of a tenant, and basically just returns those namespaces, which is a great benefit and is the main point of this slide. So we have also designed a feature where we would deploy a Tecton dashboard per tenant, so they would have their own Tecton dashboard. And with the Capsule proxy, so if the Tecton dashboard uses the Capsule proxy as API endpoint, you can basically list then the namespaces in the web GUI, and it kind of works more smoothly. Otherwise, you're not able to do that since users don't have that privilege. And yeah, basically, there's a simple example for a simple tenant which has these two namespaces where you have a quota which is synced between these two namespaces, and where it's ensured that your given ownerships and network policies and role bindings are replicated within these two namespaces. So that doesn't work as well. So what's below these code snippets is basically we built additional abstraction. So it's basically a Helm chart, which is a wrapper around the tenant CRD, which we use from Capsule, which helps us to deploy additional features. So we're actually using the Capsule CRD and trying to build something on top which satisfies our platform users. And in that use case, it would be as mentioned, we would deploy a Tecton dashboard, or for example, a dedicated Prometheus instance, or the logging feature we had previously with a dedicated Grafana instance. What I basically want to show here is, yeah, okay, we did that. It ended up being just a lot of templating and a lot of abstraction, basically what we do all day. So the question is if that's the right way to go. So here it works. It doesn't work again, but that's all right. So the benefits we had from that is, as mentioned, we could now actually operate with list operations since we had the Capsule proxy in place, and users can create their own namespaces. The entire process, so the creation of namespaces was no longer a process per se, it was more towards self-service. The drawbacks, one of the main drawbacks is whenever you start doing multi-tenancy, you will have to ensure that other tools that you integrate with the platform require additional engineering, especially talking about observability stacks, GitOps, etcd, it's much simpler to run these apps or operators on a cluster scale, but on soft tenancy, you still have some troubles integrating them, or at least you need to spend some time integrating them. We still had shared workers basically, and yeah. So the main feedback from the users, which is again in green, is first they want to deploy applications which have cluster-wide access. So for example, one of our developers wants an Argo which manages the entire cluster. Someone else told us it's not clear what the new tenancy is for and how the features really work, and it's difficult. And someone else also told us it's not really guaranteed anymore, since you have a shareability of resources on tenant basis, but it's difficult and it seems like a downgrade from classic setups. And even some of them told us we didn't even know we could create new namespaces even today. So there's some points we gotta work on. But at least we can see that our platform has grown over the years. We got more feedback, and even feedback where we can see that our developers really matured in handling the platform and want to get hands on themselves, which is really great to see. And the more feedback you have, the more you can improve, right? So here's some learnings that we should have done, or what we should have done before migrating to the new tenants. So we haven't really worked with priority classes, with preemption, because we just didn't have time, to be honest, right? You still have the problem if you don't work with priority classes that you can have noisy neighbors, especially when you have non-cloud native applications which allocate huge amount of resource, like immense. And you kind of have to work against that. And that's kind of difficult without anything like priority classes or dedicated worker nodes. Something else we've seen or should have done is our tenancy tiering and dimensions. So as of now, for example, we have tenants which have up to 50 namespaces, which is fine. But the problem with it is there's different development teams in there. There's different stages of all of these development teams in there. And how we went to create that tenant was basically, hey, who's the customer, who's paying for it? But maybe, as we can see, that doesn't scale because all of these developer teams have one resource pool, basically the resource pool the customer paid for, but it's a constant fight for resources, which isn't that great. And especially if you consider you have dev integration and prod stages on the same cluster, which right now isn't the case. And the tenant ownership is, we sometimes don't even know who a tenant belongs to be honest. So that's also sometimes difficult, and it's important to define who has the ownership. So who can actually has more privileges in the tenant, who can order more resources, etc. That's difficult to track. And we should have also improved the resource situation and create incentive for resource reduction for oversized pods. So yeah, and that's also basically the two biggest points. If you're looking into tenancy, you should really look into these 2 points. So how can you distribute your workload? Are you able to create dedicated worker nodes per tenant? Great. Are you able to create dedicated worker nodes per stage? Whatever. Will you have shared workers? How can you ensure these shared workers don't end up to look like a war zone? So do you create priority classes? Do you create abstracted priority classes from your SLA? Do you enforce these SLAs based on priority classes? And the next point is the tenancy tiering. So the last point I talked about, how does a tenant, what's a unit? What can be a unit for a tenant? How is it scalable for you? Is a customer a tenant? In our case, no, that's wrong. But is a team a tenant? Is an app a tenant? How does that look like? And how do you protect critical workload from development and test? Can you do dedicated tenants? Can you do fixed quotas for critical namespaces? Can you split it by worker nodes? Just think about these points. So I want to take a quick look at where we are heading. So I'm trying to make this a bit faster. So based on the feedback, we are looking right now into virtual clusters, so control planes as a service, where we can basically make control planes as a pod. So then we can start scaling based on dedicated worker nodes. And basically, what we want to truly offer is a true managed Kubernetes, which can be used however you want it. And with on top of that offering, we still want to continue with our community clusters, so with our tenancy, including Capsule, but with some of the learnings. So rework the entire tenant dimension, rework observability stack, maybe even we're trying integration with Teleport for external access. So all that good stuff. So the workload would then workflow would then look like the customer would again need resources on Kubernetes. Based on his requirements or expertise, he can now get either a vCluster or control plane, or he can still get a tenant on a community cluster, whatever he needs. So a vCluster for us would look like something like this, that the control plane, so etcd and all that good stuff, is all abstracted in pods. And along with the entire control plane components, we install a machine controller, which is responsible to create machine deployments on the new control plane, where you basically stage new machines on Qubit, vSphere, Nutanix, whatever you need. Also, on that same level, we're going to implement the cluster autoscaler and something like KubeGreen, where we can effectively scale down workload clusters to zero overnight, for example, to be more sustainable in the future. So what this is going to allow us is that we have, for example, here a meta cluster where we manage different other control planes. So one use case is, for example, hey, here's your managed cluster, where we deploy that vCluster into that managed cluster namespace. And Fabio hopefully really likes that slide because we also implement CDOM Enterprise. And then you will get basically that new control plane where your basics are staged. So the network connectivity is there. We can even manage your nodes, but the customer A can also bring his own worker nodes. So all the CRDs are available for you to stage your own workloads wherever your provider is or wherever you want it. So effectively, we just host a control plane. And the two other use cases are basically, we have that community cluster where our main service is, hey, we have the tools integrated that it works with the capsule tenancy. So either we're going to just give you a tenant, which is the use case for customer C, the green one, where he just gets a part of a cluster, which is fine for him. Or we can even offer to a customer B that he can take the tenant cluster, so the entire framework basically as service, and provide the tenancy and administrate everything himself for his own customers. So that's basically where we're trying to heading to satisfy all the needs. So what we expect from that is basically that we have a solid managed Kubernetes offering with different cluster flavors we can offer and be fast with it. And we want to simplify operations since we still have a shortage of workers. We want to optimize resource consumption and implement autoscaling for sustainability in the future. And we want to move towards pay-per-use models if that's possible in the future. So if you thought that's actual genius, there's an alternative where you don't have to build that yourself. And that's again from our friends at Plastics. They have their solution Kamachi, which basically does the same. It also shares the etcd, so it goes a bit further regarding sustainability. So if you think that could be also something for you, definitely check out their project. So that's basically it. That was our journey on Kubernetes or with tenancy. I hope our customers will be satisfied in the future. And if you have any questions, let me know. I'm available on the Slack Kubernetes, or you will find me on the Capsule Slack channel. So yeah, but thanks for your time and thanks for the opportunity for being here.
Okay, thank you, Oliver. You got a lot of compliments about your hat in the chat. A lot of people really enjoyed it. So you had already, also a lot of questions. So the first question comes from Alessandro Finito that asks, how would a capsule tenant restrict a cluster role? Would the development team be able to deploy something like a Streamsy or Cassandra operator without failures?
So we have Streamsy in operation, so we also do Streamsy. And basically you map then these roles. So you have this cluster role, for example, you can create your Streamsy cluster or whatever, and you map this role based on the tenant. So on your tenant, there's this role, Streamsy. I can view the Streamsy cluster, I can create a topic or a user, and you basically distribute that per tenant, or you still deploy your own RBAC per namespace. That's also what we do. So for example, in production, they cannot create topics, but in the test namespace, they can create topics. So
Okay,
it's native managed.
it's simple as that. Okay.
Yeah.
Okay. Okay, great. You got another question. Actually, one of the participants has already answered, but I think it's a cool question. So, what if you create the tenant once those cluster roles are already deployed? This is the question that Alessandro asked.
Sorry, I didn't get that. I have to read
Yeah,
it.
I don't know if from the... Riuscite a metterla in screen così la vede? Quella di Alessandro ha finito? What if you create the tenant once those cluster roles are already deployed? Okay, you got it on the screen now.
I'm not quite sure, actually. I don't know, maybe Dario understands it, but as said, you just create role bindings, right? So
Yeah.
I don't know if it's related to the operators cluster privileges, but other than that, you have to. It's a framework at the end, so you design your RBAC how you, example, use cluster roles yourself. So that's all native. Yeah.
Yeah, and I think it's limited even to namespace, so maybe it's not necessary. Okay, so I think that's it. Thanks, Oliver, for joining us on the KCD. Your talk has been very interesting, so I hope to see you again for the next edition.
Thanks, guys. Have a nice one.
Have a nice day. Bye, Oliver.